Hi friends, welcome to my channel. In today's session, I am going to explain Sidgwick theory or effective atomic number rule, and Sidgwick theory was proposed by Sidgwick. Before we are going to calculate the effective atomic number of metal in a complex, we have to know what is meant by effective atomic number. The total number of electrons available around a metal in a complex is known as effective atomic number. In a complex, the total number of electrons around a metal is known as effective atomic number. In another way, the sum of number of electrons on metal and number of electrons donated by ligands to metal is known as effective atomic number. Totally, the effective atomic number means the total number of electrons around a metal known as effective atomic number, or the sum of number of electrons on metal and number of electrons donated to metal is known as effective atomic number. And the formula for calculate effective atomic number is atomic number of the metal minus oxidation state plus 2 into coordination number. Coordination number means the number of ligands attached to metal known as coordination number. So, see what is meant by effective atomic number? Total number of electrons available around a metal known as effective atomic number, or sum of number of electrons plus number of electrons donated by ligand to metal known as effective atomic number. And the formula for effective atomic number, Z minus oxidation state plus 2 into coordination number. Z means atomic number of metal and coordination number means the number of ligands attached to the metal. See, the complex in which metal atom effective atomic number value equal to nearest inert gas atomic number, those complexes are stable. The effective atomic number of metal in a complex is equal to nearest noble gas configuration. Nearest to noble gas or inert gas configuration means that complexes are more stable. The effective atomic number of metal in a complex is equal to noble gas configuration of atomic number. Those complexes are stable. When we find effective atomic number, that effective atomic number value of metal in a complex is equal to nearest noble gas configuration atomic number, such that complexes are more stable. So what saying effective atomic number or Sidgwick theory? The complexes in which effective atomic number value of metal is equal to nearest to noble gas configuration are that complexes are more stable. Let us find some examples. The noble gas configurations atomic number are 10, 18, 36, 54, 86. Neon, argon, krypton, xenon, radon. Effective atomic number value of metal is equal to these noble gas atomic numbers are more stable complexes. Let us find some examples. NiCO4, nickel tetracarbonyl. See, first we have to find atomic number minus oxidation state plus 2 into coordination number. We have to find the oxidation state of metal. Based on in previous tricks, all the metal carbonyls, the oxidation state of metal is 0. So, the oxidation in this complex nickel oxidation state is 0. Atomic number of metal 28 minus 0 plus 2 into coordination number. 2 into what is the coordination number in this complex? Coordination number means the number of ligands attached to the metal. How many number of ligands attached to the metal? 4 ligands. So, coordination number is 4. Total 36. The effective atomic number of metal in this complex is equal to nearest noble gas 36 means this complex is most stable. See FeCO5. Effective atomic, what is the formula? Atomic number minus oxidation state plus 2 into coordination number. What is the atomic number of the metal iron? 26. And all the metal carbonyls, oxidation state of metal is 0. 0 plus 2 into how many number of ligands attached? 5 ligands. 5 means this is the coordination number. So the effective atomic number value of metal in this complex is 36. This 36 is nearest to noble gas. So FeCO5 is most stable according to effective atomic number rule of Sidgwick theory. Next example, see here KBF4. First find the oxidation state of the metal. What is this? Ionic complex. Ionic complex means both in this complex having both coordination sphere and ionic sphere. What is the formula? Oxidation state plus charge of ligands plus ionic sphere is equal to 0. Metal oxidation state do not take an X plus charge of ligands 4 into F is plus ionic sphere K is equal to 0. X plus what is the charge of fluorine? -1 plus potassium charge 1 is equal to 0. X is equal to plus 3. EAN is equal to, what is the atomic number of the metal? Boron 5. Oxidation number 3 plus 2 into coordination number of ligands attached to the metal. What is the coordination number? 4 is equal to 2 plus 8, 10. 10 is the nearest noble gas configuration atomic number. Neon atomic number is the 10. So 10 is the noble gas. In this complex, effective atomic number value of metal is nearest to noble gas. So this complex is more stable. And then all in the next example, En value is equal to Z minus oxidation state plus 2 into coordination number. We have to find first oxidation state. Based on the above in previous tricks, the coordination sphere contains only neutral ligands, means the oxidation state of metal is equal to charge on the coordination sphere. What is the charge on coordination sphere here? +4. So if the coordination sphere contains only the neutral ligands, means the charge of the oxidation state of metal is charge on the coordination sphere. So oxidation state of this metal is +4. Atomic number of platinum 78 minus oxidation state 4 plus 2 into how many number of ligands attached to metal? 6 ligands. So coordination number is 6 is equal to 74 plus 12 is equal to 86. So 86 is the nearest noble gas configuration atomic number of noble gases. So this complex is also most stable. Why? Because this effective atomic number value of this metal attains noble gas configuration. So this complex is more stable in the nature. Next example, which of the following is most stable? FeCN6 4 minus FeCN6 3 minus. In these two complexes, which complex is more stable? Based on the effective atomic number, we have to find which complex is more stable. Effective atomic number is equal to atomic number of metal minus oxidation state plus 2 into coordination number is equal to atomic number of metal is 26. Oxidation state of metal is X plus 6 into the charge is equal to -4. What is the charge of cyanide? -1. So the charge is +2. 2 plus 2 into number of ligands attached to the metal, that is the coordination number. How many ligands attached? 6. So 6. 24 plus 12 is equal to 36. This is the most stable. Why? Because the effective atomic number of metal attains nearest noble gas configuration. So this complex is most stable. And then again for what is the oxidation number of this metal? X plus 6 into Cn is equal to minus 3. X plus, what is the charge of the cyanide? X is equal to plus 3. Effective atomic number is equal to the atomic number of metal 26 minus oxidation state 3 plus 2 into coordination number. Number of ligands attached to the metal is known as coordination number. So 6 ligands attached. Coordination number is 6. 23 plus 12. What is 23 plus 12? 35. This is less stable. This is not the atomic number of noble gases. 36 is the atomic number of noble gases. So when compared to FeCN6 4 minus, FeCN6 3 minus, FeCN6 4 minus is more stable when compared to FeCN6 3 minus. Why? Because FeCN6 3 4 minus attains noble atomic number of noble gases, and FeCN6 3 minus does not attain noble gas configuration. So which effective number of the metal in the complex attains nearest noble gas configuration means those complexes are more stable. That's why FeCN6 4 minus is more stable. So this is the way to find effective atomic number value of the metal in a complex. The metal which attains noble gas configurations atomic numbers are more stable. Thank you for watching my video. So please like, share and subscribe. Thank you.